Module 9, Acid-Base Chemistry, recognizing acids and bases from their chemical formulas. Have you noticed so far that most of the acids we've looked at have a hydrogen atom as the first atom in the chemical formula? If you did the on your own questions just before this section, there was only one that did not have that configuration, C2H4O2. And with the exception of NH3 and CaCO3, all of the bases we used so far have had the hydroxide ion. This is usually the case. Most acids will begin with an H in their chemical formulas, and most bases will have a hydroxide ion. Knowing this will be helpful for you to better determine acids and bases. So if you saw hydrogen fluoride, HF, you might expect it to behave as an acid, while methane, CH4, would likely not behave as one. And you might expect rubidium hydroxide, RbOH, to be a base, but maybe not octane or C8H18. What about CH3OH, which is methanol? It ends in an OH, but you need to realize that this is not an ionic compound, so it cannot contain ions. Remember, an ionic compound has to have at least one metal atom and one nonmetal atom, and this compound does not. So though this is a bit of an easier way to determine acids and bases, know that you need to understand the why behind what they are. So looking at how they behave in a chemical reaction is a better way to determine them. Knowing all this will help you even be able to predict which compounds will act as acids and which will act as bases too. Additionally, you may have noticed that I have been referring to some of the acids by unusual names, other than the naming conventions we learned about. That's because acids have special names that don't follow the rules. So though HCl is officially hydrogen monochloride, I have been referring to it up to this point as either HCl or hydrogen chloride for ease of word usage. But it is more chemically accurate to call it either hydrogen monochloride or hydrochloric acid. Other common acids can be seen here: hydrobromic acid, hydrofluoric acid, nitric acid, sulfuric acid, phosphoric acid, carbonic acid, and acetic acid. You don't need to memorize these names, but know that I will be using them as well as their chemical formulas, so you will become more familiar with them. You are likely familiar with several common names of acids, and you can find many of them at your local hardware store. Hydrochloric acid is used for deep cleaning of hard water stains on porcelain and in swimming pools. It's called muriatic acid, which is about 30% hydrochloric acid. You can find a more dilute form of hydrochloric acid in toilet bowl cleaners. Not only do you drink acids in the form of lemon juice in lemonade, if you drink soda, you're drinking carbonic acid, a mild acid from the carbonation process. Vinegar is made of a mild acid called acetic acid, and sulfuric acid is found in some fertilizers, detergents, and even pigments. Now, the naming of bases is a bit more straightforward. They follow the standard naming rules. So, the base SROH2 is strontium hydroxide. The ionic compounds that are bases are all named according to the ionic compound naming rules. Now, bases that do not behave as ionic compounds are named otherwise. NH3 acts as a base even though it doesn't have a hydroxide ion. Its proper name is nitrogen trihydride, but it's more commonly called ammonia. As you work with more of these compounds, you will become more familiar with their names.